almost all instances in your real life application, right? You go to a movie theater, you see a queue to get a ticket for a movie or go get a popcorn. You see queues almost like everywhere. So let's come to the most realistic way. How does a queue work? Suppose that this is my ticket counter. Okay, so this is my ticket counter on house, and a person comes here. He gets a ticket. Okay, there's another person who's also standing, waiting to get their tickets. And you, from here, you come and you append yourself to the queue, right? You're not going to, come here and ask this person, can I join? Most probably you won't, right? That's not how it works. So you go join yourself at the end of the queue, right? So this is how it's going to work. So what do you call the person standing here? You call the person standing at the front, right? Yes. So in notations of queue, right, you call the person who's standing at the end of the queue, right, to be at the rear end. So what is the end? So suppose that this queue can have, it's having 10 places, right? So already 3 people are standing, and you're going to join in the 4th position. Alright, and it has this 10, it can hold up to 10 people inside this queue. So what is this 10? This 10 is basically the capacity of the queue. Alright, so the queue can hold up to 10 people. So right now, what is the size of the queue? The size of the queue after you join in is going to be 4. That is, the queue has a capacity of 10. But right now, the size of the queue is only 4. And after you, some other person is actually going to join, right? Join after you. Then what is the size of the queue? The size of the queue will become what? 5. But the capacity of the queue is 10. Capacity is the maximum value that a queue can actually hold. And size, this 4 is the size. Okay, and afterwards it becomes 5. Alright, size is basically what? It is the number of people actually present at a particular point in a queue, right? So the size, the last most person that's present in the queue is said to be where? At the rear end. He is the last most, right? So he is said to be at the rear end. So there are 2 operations that can possibly happen in a queue. One is you can come and join yourself to the queue. What is that? You are entering the queue. Alright. So firstly it's NQ operation. Alright, that is you enter the queue. Second is you get the ticket, you go out of the queue. Right? So that is going to be what? That is going to be DQ operation. Alright, so these are the only 2 operations that can be done in a queue. Alright, so one is NQ operation and the other one is going to be DQ operation, that is deletion. Fine. So deletion happens from where? From the front end. Alright, and the entry happens where? At the rear end, last end. So with this, okay, what do you understand? The queue is going to work in first in first out format or a last in last out format. That is, the person who comes first gets his ticket first and gets out first. Okay, so the first in is going to go out first. So first in first out structure. You can also call it vice versa, last in last out. So the person who's entering the last is going to go out at the last. Right? So that's how things work in a queue. So queue is going to follow a first in first out structure. You can also call it as a last in last out structure, and there are only 2 operations that you can perform in the queue. One is entering into the queue and the other one is getting out of the queue. Alright, that is deletion operation. And what are the variables that a queue holds is that front is the first variable. Second is the rear. Alright, third is the size. Size tells you how many members are going to be present at the queue at a particular point of time. Okay, right. Capacity is the maximum value that a queue can actually hold. Alright, if you want to use vectors, right, you need not have to use capacity at all. You need not have the variable. But this one is pertaining to the array implementation. So if you are going to work with arrays, you have to have some end limit, right? But whereas for vectors, you need not have the end limit. The vectors keep growing. That is one of the advantages of using vectors over arrays. We'll look at that later, alright. You also have a standard template of queues to actually implement it without having any kind of array implementation of us. But first of all, let's understand queues more clearly using the array implementation. Alright, and then let's look at the SQL type of queues. Fine. So right now, if at all, I have to create a queue. Alright. So what do I need? I need these 4 instances. But most major of all, what do I need? I actually need a data structure, right? That is going to be array. So I want something to hold all my values, right? And I'm going to use array for this instant. You can use an array. You can also possibly use a linked list. And thirdly, we'll be using STLs. Fine. So first of all, we are going to start with arrays, and second, we'll have the linked list formation of using queues, and thirdly, we'll have the STL type of implementing queue. Fine. So let's start with this array. So let me have a class. Okay. In order to hold all these, when should I use a class? A class is basically what? It holds different data types under a single roof, right? Collection of values of different data types under a single name is called as a class, right? So let me call this class as queue. Alright. So what are the different data types I'll be having? I'll have a front. Alright. I'll have a rear variable. Front is none, rear is none. Then I'll be having size. Fine. Then I'll be having capacity. So lastly, what should I have? In order to store all these values, right, what do I need? I need an array of, so suppose here I am going to have integer values, right, rather than this, something like 6, 5, 3, 2, 1, something like this. So let us have an integer, right? So this is my class queue. So since I want to hold different data types under a single name, I'm using classes, right? So this is class queue. So whenever I create an object for this class, different queues get basically created. Fine. I hope it's clear so far. So now let's have a function, alright, to create a basic template of queue. So what do you mean by the basic template? Right now we have a variable called front, alright, but is this variable assigned right now? No, right? Is this real variable assigned right now? No. So why do I want this front to hold? I want it to hold at the 0th index, right? And similarly, why do I want the rear to hold? I want the rear to hold at the lastmost position. What is the lastmost position? That is going to be my capacity minus 1 initially. During the basic initialization, the rear is going to be capacity minus 1. And size for a newly created array is going to be 0, right? There is no size basically. So initially it should hold value 0, this also 0, and this is going to be capacity minus 1. Capacity must be an input from the user. Alright, and then using all of these things, I have to create an array of size that is equal to the capacity. So this is going to be my initialization function. Okay, initialization function. So how do I create this initialization function? So initially, what should this initialization function do? It should basically create an object for this queue and initialize all these values as 4, and then it was written the queue, right? So let's look at that. So basically, right, the initialization function for that queue is what we'll be looking at right now. So let's create a function. Let the function name be create queue. Fine? Yes. So what should be taken as input for this function is the capacity of the queue, right? It is the input. So in capacity. Fine. So at the end of this function, what should it return? This queue, this create queue function was written as a queue that it actually created with these initial values, right? So it is going to basically return as what? A queue, right? An object of this type. Fine. So let's have this. Alright. So the first step is going to be create an object of class queue. Alright. So q star q is equal to new queue. So this is how you create an object, right? So if at all I give it as a pointer and if I don't give it as a pointer, what's the basic difference? Is that it's in the way you refer to the variables. Alright, if I give it in this manner, right, the return type will also be this. Okay, and to refer to all of these variables, I use a dot operator. It's going to be q dot front, q dot rear, something like that. But if at all I'm going to use a pointer, the way I refer the variable is only going to change. Alright, so right now I'll be referring to all of these variables of the class using the arrow function. Alright, so it's going to be q of front is equal to what? The initial value must be 0. Alright, and then q of rear must be equal to the capacity minus 1. Alright, and then q of size must be equal to 0. Alright, because initially there is no element present in the q. Alright, and then q of capacity, it must hold the same value that is given as input is equal to this capacity. And then what should be, the size of the array? The size of the array, q of array, right? This array must hold a size that is equivalent to the capacity. Alright, so if at all I tell the capacity is going to be 5, I must have this, right? The array must have this much allocation, so it should hold up till index 4. That is meaning of capacity 5, right? So q of array is equal to what? New int of how much? Every time I tell 5, it simply means it's going to give me an array of size 5, right? So right here, instead of this 5, what should I have? It should hold the capacity, right? The size of the array must be equal to the capacity of the q. So it is equal to what? General capacity. Alright? Yes. So at the end, you are supposed to return this object of the class q. Alright? So this is going to be what? Our initialization function. So right now let's look at the enqueue operation. Alright?